Hello, everyone. Again, this is Mike Hicks. We're working through the first practice exam for Business Administration 602. And so, what we did in the poor audio version before is essentially lay out this sort of statistical work. And then in the class that I gave you in supply and demand, we did the model. So, I'm just going to flip back and forth between what I have done on the spreadsheet and what I'm doing here. And I'm not going to write everything out on the paper that I'm looking for, but bullet points and a sentence or two should be sufficient. I'm not. I'm looking to see if you understand it. I'm not looking for a perfect and clear explanation. I assign papers, and there I'm looking for your communication style. Here, basically, I'm trying to get some inference on your understanding. Um, and let me just make another comment about this. For those of you who are good at Excel and are very good at working software, this may not be very challenging. The ideas are important, of course, and the ideas will get more challenging in the remaining weeks of the class, but the actual manipulation of Excel is not. And the reason I'm having you do this and the reason I'm not giving you clean data is because you are going to soon inhabit a world in the later MBA class where you're going to have to clean your own data. You may have to find it. And I've shown you where that data is available in a number of locations, and you're going to have to manipulate the spreadsheet or the statistical software, and each one of them has small differences. You have to align data up in a certain way, you have to array it in rows or columns, and just being able to do that work is part and parcel of mastering a graduate program. And so I can't teach you everything that could possibly go wrong in Stata, which is a statistical program, or SAS, or eViews, or R if you're going to code this, directly. There are just too many, literally infinite problems, and so you're going to have to problem solve this yourself. So don't think that there's not a purpose behind you doing these problems and me giving you incomplete data. I want you to understand and to work through those things and to figure them out. And by the way, I don't use Excel in as a statistical software other than to do summary statistics. I use different software, two or three different packages, and so I've had to struggle through a fair bit to learn the Excel portion of regressions. And what I mean by learn is, how do you array the columns? How do they take a value that's emitted? When you do inputs of multiple variables, how do you manage that? And you can read the book. There's plenty of ways to do that. There's help material online, which is the book, or you can brute force it, or some combination of the two. So let me begin. This is the practice exam. The answers here are going to be in yellow, and then there's going to be, of course, in the statistical portion or in the software, the spreadsheet, you'll see the individual components. So question one was very simple. Illustrate a graphical example of a supply and demand model for housing and write this model algebraically into equations. Well, I didn't draw that. You have seen that in previous examples. But here is the price of the price demanded is equal to A minus BQ. This is the downward sloping demand curve. And then the price supplied is C plus DQ. That's the upward sloping supply curve. So D should be positive and B should be negative. And then this is going to be that traditional supply and demand model from the lectures 5 and 6. So question, and that's what I'm looking for, a graph and this. Using data provided on Texas counties, provide summary statistics for all economic and demographic variables. All right, so what did I do? So let me just click back and forth. This is the basic data. Okay. In order to do the data that I needed, I had to look around, and it turns out that I'm going to need to do some extra things. I'll write those down in a minute. I needed to create the wage per person variable, which is simply the wage divided by the total population. There's two total populations here, it turns out, and we'll talk more about that in a minute. I had to omit some variables. All of these, and I'll show you what the variables are, we're missing data points. And every data set you observe that has multiple locations or multiple people or multiple homes will have omitted variables. And some software treats omitted variables as zero, which will destroy the quality of your analysis. Some omit that observation with omitted variables, and some make you remove them entirely from the process yourself. So that's a manual process. It turns out in Excel they force you to do that. So I had to, Texas has 250 counties, and I omitted all those with no observations of housing prices. Those are counties that didn't have sufficient housing prices for transacted properties that they could be included in the model. And these are those. I kept the data. It's good to keep original data and a working version as well, and did that. So here's the summary of descriptive statistics, right? Here's total population. Mean is 98,000. Total population 2010 is 95,000. Median age in 2010 was 38.4 years. Total number of households in a county, the mean was 33,618. Wage in 2010, these are total wages, was 197 or 1.97 million, which these are in thousands, so 197 million dollars was wages. Housing units 38,000, and then this is the HPI with base was an average of 139 by 2000, and the wage per person is 12. This is thousand, so 12,807, right? Was the mean. There was a median was 11,000, and there's no mode. There was no single county where we had the most observations. Right, so, and by the way, this is not the way Excel produces it. Don't be obliged. In fact, you should not just simply present information the way the software does. Present that which is interesting. So the mode's not interesting, so I might cut this in a table, and just for our purpose here, I'll black it out. We have standard deviation, we have the sample variance. Well, that's just the square of that, so that doesn't tell us anything new. We like parsimonious tables. The range may not be very important. The min, the max might be, right? But so there's counties where total population is 82 and 41. So that's how we would present these data, and many papers will have you do that as a matter of course, that they will, or many studies you'll want to present the summary statistics. So, an observer can look at your work and say, oh, okay, now I understand what they're doing. I understand the range of this analysis. Okay, so let's go back to our test. So now it says provide the summary statistics. I did that. Now construct a reduced form supply and demand model using only price and quantity. So in equilibrium, price demand is equal to price supplied. So that's just call that price is equal to, and we set the other two equal, A minus BQ minus C minus DQ. And then we work that out. It's A minus C minus D minus BQ. And here's the problem with that. That doesn't tell us anything. This is an intercept, right? And then this mixes the supply and demand equations here. In later classes, empirical classes, will show you how to fix a model so that you can do supply and demand, but that's part of what economists call identification strategy. Allows us to isolate those effects, and that's really PhD level work or advanced master's work, not an MBA work. And so I'm going to skip past that. Okay. Now, so let's see what this looks like. So here's the reduced form model. These are the outputs of it, right? So we have on the the left-hand side variable is price. It's not reported anywhere. And the right-hand side variable here is housing units. The coefficient is negative 1.4 e to the negative 0.5, which is 4. It would be advancing the 4 zeros above that 1, so it's a very small number. And then this t statistic of that variable is under 2. It's still statistically significant, but only at the 10% level, right? So you can convert these into percentages to see that that's 7%. But that we know that that's still statistically significant, but that's a small effect. So you can't really interpret this because this is both the supply and demand coefficient there, but it's small and doesn't tell you a lot. The overall equation is not very strong. The F statistic here, another signal to noise ratio. The overall variance of the model is only 3.3, so statistically significant at the 0.10 level. So it's between 0.10 and 0.05, which is, you know, uh, not statistically significant at the 5% level, but statistically significant at the 10% level. Again, that's pretty small. And in this case, it only explains 2.4% of the variance. So that supply and demand model doesn't do very much for you, and there's not much to explain, simply that it doesn't matter. And by the way, that is often an unimportant and unrealized important portion of this analysis. Anytime you're doing this work, be it gender, be it the effects of what gender wage gap, or what causes difference in household income, or why some places grow and other places don't, or what's the probability that somebody's going to enlist in the military. Those are all studies that people have done. There are a lot of variables that don't matter, and that's the purpose of multivariate analysis. Is we can look beyond a single variable. And so in this model, housing units by themselves just don't seem to matter very much. They're not very statistically powerful. The model itself explains a terribly small proportion of variation. And now usually these cross-sectional models of 133 counties are going to get low values, but 0.02 is very little variance, and then that number is really, really small. The number of housing units, like it takes 10,000 housing units to have a 1-point effect on the price. And by the way, that's important because it turns out when there's a lot of researchers who have done analysis in this area, SFI, they found that big quantity changes if population is changing and home building is going on doesn't really affect price very much. So a place like Houston, where homes are being built like crazy, prices don't go up really high. But a place like Muncie or Toledo, where people leave, prices really drop. So this is consistent with what we observe in actual other research studies, which is why you read other people's research to see if you found something, outlandish, or does it make sense. And if you can't, your goal is to try to evaluate that in some meaningful way. So let's go back to the questions before practice exam 1. So in this model, I've explained the signal to noise ratio. The signal to noise ratio and how they affect our interpretation in the model. So you're going to explain what I just said, which is just that model doesn't tell you very much. So now we're going to a reduced form model of housing in Texas using additional variables, and you can use whatever you want. At least include one other variable. I wanted you to include wage per person in this case because I wanted you to make the variable yourself and how they affect that, and then explain the signal to noise ratio. So that's the reduced form model. So price is A minus C minus D plus B, Q plus Z times that average wage. And so let's look in this example what that final model looked like. All right, so wow, this is interesting, right? So in this case, we found housing units doubled in matter of importance. So here's the reduced form. That's 1.4 e to the 0.5. And in this final model, they jumped up to negative 2.7. So they almost doubled. They more than doubled in size. So when we account for wages per capita, the effect on housing units went way up. And look at the statistical significance difference. It went from negative 1.8 to negative 3.3. Now this is statistically significant to the 1% level, almost to the thousandth percent level, right? If you round it that way, it's not quite there. And so that's interesting because one of the things that we often talk about is that if you control for additional variables in a multivariate regression, it may cause some variables to drop in significance because they all influence each other. They could also make them more significant. So that's the importance of building, looking very carefully at the data and forming what you do based on some sort of scientific view. And here's the coefficient on wage per person. It's nearly 1, so that's saying for every 87 cents increase, or in this case it'd be $87 increase in, sorry about the emails I'm getting, in wage per person, you get a 1 uh, uh, unit increase in the index of home prices, and that variable is very statistically significant. Again, and we don't present them in percentages. This is just for you to see at the more than 1% level, but less than 1,000% level. So that this is a better model. The F statistic that measures the overall variance of the model itself went from 3 to 7.3, and the statistical significance there, really blossomed. Now it's at the, 1/10,000% level, and the amount of variance explained went from just over 2.5% to 10%, which starts to be a meaningful amount in a model like this. Okay, and so that's what I'm looking for in the analysis, and then words that describe what we do. Now let me show you what I wrote about here. So what I just explained is how you would write that. I don't want to make it too monkey see, monkey do in this. I wanted you to be thinking about this, and I appreciate the difficulty you guys have in software. Trust that only software classes I have ever had involved punch cards, and so I was a very good punch card user in the early 1980s when I was an undergraduate, so I am sympathetic to those of you who are older and going back to school and do it, but I also know my own intellectual limitations, so I know damn good and well that if I can figure this stuff out, you can too. Just be patient. Right, so that's question 3. And then question 4 explains specific problems with the data and what adjustments you made. So this is important. I had to omit the 0 values in home prices and create a wage per person variable. Right, I used the WP 2010 for no reason. That's just the census number, but the other is a BLS estimate. So if you go back to the original data, right, what you see is there's 2 different population numbers. And here's an important thing that I want you to see. It turns out that you can do data analysis on all of these variables before you start doing your big model. Sometimes it's good to see if they're statistically significant, but as you can see, it may be that their statistical significance of a variable isn't as important as its overall contribution to the model. So a variable may not be statistically significant, but it could be critical that you include that to make the model work. All right, so and let me show you an example of this. So I plotted this. These are 2 different total population measures. I plotted them, and they are essentially the same variable. They explain 99.99% literally of one another. So it turns out that those 2 variables, one was a census 2010 data taken in March, the other one is the average of the monthly populations reported by the Bureau of Labor Statistics. When you're doing studies like this, it doesn't matter very much which variable you pull out, in part because if you're taking the change between them as part of that variable, there are very few places in the country where that, and certainly here in Texas, where that would matter. So those 2 population data are for all intents and purposes the same thing. And that's really the exam. I want you to write in a paragraph or 2 what I have said for each one of these questions. I would wish that you copy copy and paste the material from the spreadsheet into the Word document, and that will be what I'm looking for in the test when I post it. And so let me just recap. I'm going to, in the next couple of days, based on your feedback post the first examination, I'm going to give you several days, well over a week, to complete it and repost it. At the interim, by early next week, I will post subsequent lectures. Will go on with the class. Um, we're not really behind in the materials, but I want to make sure that we're not taking a week off to do the test, that we're also listening to the upcoming material. And again, the challenges that you face in doing this work are, a portion of them are intentional. It's far better that you have had experience working with data, looking at summary statistics, making basic comparisons, understanding signal to noise ratios, knowing where data is found, knowing how it relates to theory before you get into the other MBA classes. And that's what we're going to do in this class. That's what we are doing in this class. So that as you get to the end of this, the idea is to get you ready for those next classes, so that when Dr. Liu or Dr. DeSica start teaching you health economics, statistics, or managerial economics, that you're able to at least understand what it is and how they are doing the modeling that they are doing. And with that, I will end this lecture. Good luck on the exam. If you have questions, please email me. Thank you.